Thanks everyone. We've got Justin and Tom here to talk about the Pursley banking application. I think we've already got 45 minutes. I think there's a demo as well, so I'll hand over and we'll crack on. So over to you guys. I don't know who's going to go first.
Sure, thank you. So yes, we've got lots of demo content, so we'll try and get through the slides. Just if you want to go to the next slide. Just a bit of an intro on who we are. I'm Tom Slattery. I'm CICS Test Modernization Lead at IBM, and I'm also part of the CICS Customer and Production team, which is what we're going to be talking about today. Justin, do you want to give an intro?
Yeah, so I'm Justin Taylor. I'm an intern here at IBM, so I'm on my placement year at the moment. I'm studying at Nottingham Trent University, and I study computer science as well. So yeah, I'm in the CIP team, been working on with Tom on this project, and we're excited to show you what we've been up to.
Cool, thank you. So what we're going to be talking about is an open source application called CBSA. But to give you a bit of context around CBSA and particularly why we're looking at automation for development of CBSA, I'm going to do a quick intro to the customer and production team. So I assume since we're on the CICS track, lots of people are familiar with CICS. CICS test is obviously something very important in IBM because we're aware that CICS is used in a lot of mission critical systems for our users. So it's very imperative for us to ensure that CICS is tested, is secure, and new CICS releases don't regress on any features that customers rely on. And we realized that achieving this goal takes a little bit more than just integration testing and regression testing, that kind of very specific test of CICS applications or CICS itself as a platform using sort of unit testing, that kind of thing. We realized that there's actually an area that sort of misses, which is the kinds of situations customers encounter very frequently when actually running CICS applications. So we wanted to cover that kind of broader user experience testing. So we created the customer and production team a couple of years ago. The goal of the team is to gather together several experienced CICS application developers to actually develop an in-house CICS application. And in doing so, we're walking through a lot of the processes that that we know customers go through. So covers all kinds of stuff in application development, but also system administration, rollout of new releases of CICS and seeing how that affects our production system. And it also gives us an opportunity to try and embrace some of the new technology that IBM is pushing to customers in our own in-house way and seeing how it interacts with CICS. Particularly want to highlight James O'Grady in this team as well. I put everyone's contact info so you can talk to us, but we'll be using James in particular. We'll be picking on him as our user persona for all of our demos. Let's go to the next slide. So just to reiterate on our aim in customer and production test, we want to act as the first customers of CICS. So before CICS reaches customers, it will go through our production system and we will use it. And this is a customer-centric approach. So we aren't just approaching testing by testing CICS specifically as a platform. We're testing it as users would. And we're doing that by developing an application which is based on our experience through customer advocacy and user interviews that we've done over the past years. Several members of the CIP team are customer advocates, and some of them actually come from a background of working in the other companies which are customers of CICS, customers of IBM. So they bring that experience to our team. And one of the most important clauses in that is that ensuring both continue to function. We really want to ensure that our application that we run as a production system stays functional, stays secure as we roll out new versions of CICS without interruptions to the service. So if we go on to the next slide. So that application that I'm talking about there, that's something that we've been working on, and we decided that actually just keeping that as an in-house application kind of limits the scope of what it can be used for. We had a lot of development effort put into developing something called Hursley Bank, which is named after Hursley Park where we work. And what we wanted to do was to make this into something which customers also could view the source for, something that could become a kind of means of communication and common ground for demo scenarios. So that's where we started development for CICS Bank's sample application, which is abbreviated commonly to CBSA. So I'll be referring to it as CBSA. That's what I mean. So CBSA is an open source application, and we designed it to be a sort of distillation of everything that we learnt in developing Hursley Bank. And we wanted it to be something that our tech sellers could use, as well as our internal test teams and people outside of IBM as well, could see a real example of what CICS application development looks like, but also what we think in IBM CICS application development could look like. So we're using this as a demo of some of the newer technologies that we're looking at in CICS as well. CBSA is a hybrid application, so it's got several different terminal Liberty Spring Boot interfaces. So this allows us to sort of cover a breadth of the kind of interfaces that we know customers are looking at. We've also got ZOS connection, ZOS Connect, and different pluggable data stores, including DB2 and vSAN, and a subset of the configurability that we use in CIP has been included. So rather than making this a really onerous install process, we've made it so you've got some configurability, but not everything. So it simplifies that process of installation. It's been our goal to gather together a community of open source users of CBSA and contributors. And we really wanted this to be a kind of shared approach to application development and testing. So a kind of common ground where we can use CBSA to play back what we think, what we're hoping to show for our demos. And then customers also could use CBSA to illustrate to us things that they're looking at. So it becomes a means of communication. So next slide. Now, development of CBSA has been, it's a continuous process. So we released CBSA in 2023, but we realized that just putting something out as open source is never a process that ends there. There's always continuous updates required. So you can see the GitHub URL of CBSA there, so you can go and have a look at the source code. But we realized that actually releasing code into open source is not just a one-off simple process. We can't really leave code up if we know that there are things like vulnerabilities in it. And the landscape of tech is that if you use any libraries which come from other places, as we do in our Java front end for CBSA, you must keep up to date with all of the latest vulnerability patches. And as a result, the development of CBSA is continuously evolving. We always need to keep CBSA up to date so that we don't have demo code out that has vulnerabilities in it. Now, for James, who is our lead developer for CBSA, that has been quite a manual process where he will receive alerts on code scanning, that kind of thing. He'll realize that he needs to make a change to CBSA, and then he'll go through a process of making development changes, pushing those up, and then pushing them out into open source. Now, we realized that this was a good use case to target with automation. This would be a good opportunity for us to actually integrate the continuous integration delivery automation that we've been working on into a real user story for CIP. So a few specific goals here that we had to address. Firstly, automating this process would accelerate it a lot because James no longer needs to do manual testing, lots of manual processes in his development. he would just need to make code changes, push them up, and we would be able to immediately see test results from that. Now, another thing that needs to be done for CICS application development is you really need to deploy your application and in order to actually test if what you've done works. And a lot of the time that can be done through deploying a CICS region, leaving it live, having it be managed by a user, and having a user manage the compilation and the deployment of all the libraries required. But this leads to a kind of ephemeral live environment where only the application programmer, who in our case is also taking on the role of system programmer, over administrating their test environment, they end up with an environment that really only they understand. So something that we wanted to address there would be introducing configuration as code, where the config used to deploy an environment all exists as text files. So all of that is kind of hardened into an environment which is something that you can store in source code management using modern tools like GitHub. And finally, we wanted to improve the efficiency of the development by introducing automated tests. And we wanted to try and shift that testing left as much as possible. So testing happens early. Any failures that are introduced happen as early as possible with the minimum build time involved, which allows James to be more responsive and develop quickly and find problems as early as possible. Should we go on to the next slide? So this is what we have been working on developing. So this is the CBSA continuous integration and delivery pipeline. So just a quick overview, because we'll be looking at this in a demo, but the idea is that James can push code changes to CBSA to our internal repo. We've got an automated pipeline that's triggered that will build the contents of his pull request. So it will provision a CICS region running on our Z systems, and it will compile and install all of the libraries that he's working on into what we end up with is a test environment that he can run against. So CBSA running on a CICS region, running the latest version of his development code. Next up, we can test that application using Galassa in this case, and we'll be going into a bit more about what Galassa is. But in this example, it's taking the role of integration test framework. Finally, all of this should produce a report on the progress of the tests, and that should go back to the GitHub pull request that James used to trigger this automation, so we can see an overview of what happened during his run. And finally, that allows James to continually integrate and test code into the main branch of the repo, knowing that it's safe to go out into open source. And finally, once pull requests are closed, we've got a process to automatically clean up any persistent resources that have been created during the pipeline run. So what we're going to do is focus on that deploying step first. And the tool that we've chosen to use here is Ansible. Now, Ansible is something which IBM are using, particularly in CICS, we're using for all kinds of deployment and administration tasks. So Ansible is an open source automation framework. It's based on Python, so uses SSH to communicate with host systems. And you can use this to build up really complex automation that runs across multiple different hosts. We're using quite a simple model here where our CICD automation just communicates directly with our ZOS host. And particularly because it's using secure communication, it's good for any secure application deployment tasks. Some of the key features here, just a step up from configuration as code. This is all infrastructure as code. So Ansible playbooks, as they're called, are completely defined using YAML. So really our entire infrastructure for this project is all defined using YAML, which is the same language that we're using to define our configuration. YAML playbooks are readable. They're written very simply, and we'll be going into a bit of the YAML syntax in our demo. But one of the most important things is Ansible is highly extensible. So you can use, you can extend what is available in Ansible using the Ansible Galaxy collections, which is a vetted list of collections which IBM contributes to. And we're going to be exploring some of the capabilities of those collections in our first demo. So next slide. Just to specifically call out a few of the kinds of things that are possible with these collections. So we're going to be using the IBM z/OS core collection. That's going to be submitting JCL. In fact, it's actually going to be submitting JCL to start a region for us. We're going to be doing a few file management things like moving code, moving files between local and z/OS. You can get things like the status of jobs running on z/OS, running TSO commands. Layered on top of that, we've also got the ZOS CICS collection, and that's going to allow us to actually provision a CICS region from scratch. And then just a few base features that we're going to be interacting with using just the base stuff available from Ansible. So you can template files and you can run bash commands against a host. You get all the basic stuff like configuration as code and the choice of text editor, which in our case is going to be VS Code. So that brings us to our first demo, which is going to be provisioning a CICS region from scratch using Ansible. So I'll hand over to Justin.
Yes, so this is what we will be doing first, is provisioning the CICS region using Ansible. So if we go over to here, this is what a playbook looks like. As Tom mentioned, is simply just a YAML file that will hold all the config that we need. So we've got the config at the top, so we can define hosts, variable files and environments, things like that. Next, we've got tasks. So an Ansible task inside the playbook is essentially just a name followed by a collection. So as you can see here, there's a few tasks that we do, like create the CSD data set, update it, create some temp file locations, things like that. And this uses the Ansible Galaxy collections that Tom previously mentioned. So we can extend and use all the features of Ansible itself to do what we want, basically. And we just provide this playbook to Ansible, and then it goes ahead with the tasks and knows what to do. Task here at the bottom. So this is the task we use to actually create the CICS region itself. A lot of you guys will be familiar with this. So we've got the sit palms here. We can define literally the CICS region from scratch, and Ansible will deploy this with the submit task onto Z system. So we do have some local scripts here that we can run to provision this. I'll just quickly copy and paste this. So essentially what this is doing now, this is running at like full verbosity, so don't have to worry about all these logs, but we can see how Ansible is SSHing into the host and doing all the things that it needs to do.
Yeah.
So
were we to run with a little less verbosity, what you can see is the series of tasks that you've got separate themselves out in the log, which makes the logging quite readable.
And it is quite clear what we are doing as well. As you can see here, the tasks that we've named in this provision file show up in the log, so you can clearly see what is going on.
So I'm hoping if anyone's got any experience with provisioning or administrating CICS regions, some of the steps that you'll see illustrated in the CICS provision.yaml file might seem familiar as actions that you might have previously performed manually. There we go.
That was a successful provision. So now what we can do is head over to the 3270 terminal, and we can do a prefix of the region. And as you can see here, the region is now deployed inside the Z system. And what we can then do is go ahead and log into this. Sign-in is complete. And this is what CBSA itself looks like on the terminal. So I'll quickly demonstrate a few features of what CBSA allows you to do. So if you go ahead and start the first option, which is display customer information. So we can just enter any customer number here. And there we go, we get some information back like name, address, credit score, things like that. Can also view accounts of customers as well. Let's check this account here so we can see available balance, actual, and these are all on a predefined data set that Ansible has installed onto here, given our templates that we've got. So we have some JCL templates that it uses and copies over to install it onto here. And we've also got a web UI interface as well for CBSA, which looks like this. And again, this just has the same functions and they are interchangeable. So if you created, for example, a customer on the terminal, you could then search for it on the UI and it would appear. But here's just another example of viewing a customer detail. Over here we can see accounts belonging to this customer. And a lot of different functions. So you can delete accounts, create customers, things like that.
Nice. So all of what you're seeing there is available to install from the open source repo. So what we've seen there is the provisioning of a CICS region and the installation of CBSA using predefined libraries. So just a word on the requirements for that. We needed to create some automation that targets the ZOS host, so an Ansible inventory. We created a playbook that handles that provisioning. Now, the actual requirements to run Ansible playbooks against a ZOS host, you need Z open automation utilities installed on the host. You also need Python for Z, and you'll need the ability to make SSH connections, so SSH keys and all that set up. But that should be it. So once we've done that, you can imagine in the case where we've got a developer who has provisioned their test environment, they've just completed that step, but they've got an intention behind it. They have deployed this environment with the latest version of their development code, and they now need to figure out, is their development code actually any good? Does it match the specifications that they need? Has it introduced any regressions? So that environment that we created now needs testing. And to do that, we're going to use Galasa. Next slide. So yeah, our next demo is running some regression tests against this environment using Galasa. Now, just a quick note on what Galasa is. It's a Java-based test framework, which is also open source technology and is part of the Open Mainframe project, and the Z Linux Foundation. So this is all stuff that you can also use. And it's an integration test framework that works against ZOS with a kind of JUnit format. So Justin, if you want to talk us through some of the test classes that we've got here.
Yes, so this test class here is to test customer. So the customer function, so this will be creating customers, deleting them, transferring funds between accounts, things like that, or updating the customer as well, information. As Tom mentioned, it has a similar structure to JUnit tests. So here at the top, we have some things that you might not be familiar with, so annotations. So we can provide Galasa with these annotations to say, well, before we run this test class, we want to provision a customer and provision a C3270 terminal. to be able to run these tests against. And as you can see, the test code is relatively simple. And when we get on to running the test, you'll see just a few lines of code can do so much within the terminal itself. So I'm going to quickly give this project a build. Then we can run in this test.
So just a point as well is the test itself here has got no specific information which is about our host system necessarily. So the test is not hard coding anywhere what region to run against or what URLs to use or that kind of thing. All of that is configured via configuration properties passed to the Glasser framework, which allows us to create a reusable asset with each Glasser test. So each Glasser test is agnostic to the environment that's been provisioned. So these same tests could run against several different configurations of CBSA, which is really important because you don't ever just want to be testing one specific installation of an application. You really want to be writing tests that are reusable and will have a long lifetime.
As we can see here, Glasser provides us with a run log, and we can actually see what Glasser is doing to the terminal. So here at the start, we've got the provision start task. That wants to slow down a little bit. Essentially, what this will do is provision the customer and things like that we need for the test. And then the test class will start and it'll go through. As you can see here, it's filling out information. And we are just seeing if it works. Now, if we scroll down to the bottom, we can see that these tests passed. Glasser then allows you to enter the RAS folder here, and this gives you a run log. Now, if we close this terminal down, so yes, start. So here we can clearly see starting the provision generate phase. So it's logged onto the terminal, it's scrolling through, it's creating a customer for us. And now we use this customer within the tests to obviously update things like that. So we can see the customer record here successfully being created. And now the test class starts. And it goes through, and as we mentioned previously, the test class code is very simple, yet we can see all of this that is doing, it's getting to work. And then it cleans up everything at the end. It also does provide some artifacts, and we can see some screenshots as well from the terminals. They're in zip.
Those haven't unzipped.
Yeah.
Just a thing to mention on Glasser. So Glasser provides some extensible managers that you can plug into your tests. So these allow you to kind of broker connections to different systems that you may be using. And in our case, we're using the ZOS 3270 manager to interact with the terminals. But with the power of open source, that list of available functions is always growing. So more managers are being contributed, allowing richer interactions with different systems. But also you've got the ability to create your own Glasser managers for your own system. And that's been one of the projects Justin has been working on, which is to create specific Glasser managers for CBSA to allow the test code to be greatly simplified.
Yes, and here's a previous run log. The images did not load on that one. But as you can see here, this is all what you guys will be familiar with using the terminals. Glasser does this all for you, and very quickly as well. And that's just an example there of it logging on to a region. And the images don't show like any passwords and things like that. So we're safe and secure there. There's a sign on complete. And then there is options to add lines of code within the test classes to screenshot wherever you may be. So that can help with debugging as well.
Just aware of time, we may need to get onto our last demo if that's possible.
Yeah, no problem. I'll quickly run the web UI tests. So this uses Selenium WebDriver. because CBSA is a hybrid application. So we have the UI as well as the C3270 terminal, but we can let that run in the background and we'll come back to it. So what we'll go over to is to demonstrate the pipeline itself.
Just before we get to that, we've got one more slide, if that's all right.
Yeah.
Just want to introduce a bit of the technology in there. So just a word on assigning technologies to what we're using in the pipeline. So just to recap, we provisioned a CICS application using Ansible with extra collections to allow interaction with ZOS. We've now tested that application using the Glasser test framework and even introduced our own custom manager code to specifically interact with the application under test here. The last thing that we're going to do is going to wrap those two steps in a CICD pipeline. The CICD framework we're using for this is Tecton, but this is interchangeable. You could use any CICD framework as appropriate, for example, Jenkins. But for our purposes here, we're running Glasser tests in an automation server on Kubernetes. So we also wanted a Kubernetes-based infrastructure pipeline management system. So that's why we chose Tecton. Lastly, our source code management is GitHub for this. So all of this has to be triggered from GitHub and all of this has to return results back to GitHub. Yeah, so just some context. So if you want to go back to the demo.
Yeah, I think I will need to deprovision that region that we provisioned earlier. So yeah, this is just a local deprovision of the CICS region, which allows us to clean it up, and then we can get to running the pipeline itself.
Yeah, and just as a peek behind the curtain to avoid this looking like any kind of smoke and mirrors, we are doing that because we've provisioned the CICS region using the same Apple ID that we're going to use in our pipeline. So what you will see in our CICD pipeline run is a genuine new CICS region being provisioned from scratch.
While we're waiting for that, we can go have a look at the web UI tests. They should have been finished by now.
Yeah.
As you see, those have passed. We can check the run log for this. As it is Selenium tests, the run log doesn't really provide much information in regards to the tests, but we can see here on the artifacts is screenshots. So this is essentially, we've got lines of code in there to tell Glasser to take a screenshot whenever we want it to, and we can see how it goes through. It shows creating a customer and different things like that. At the moment, there's not many screenshot codes in there, but it is an option for you to do. So if we check deprovision task is finished, so now we can run the pipeline. The pipeline is triggered by a pull request being opened for a merge to main. So here's just a quick demo. We will close and open that. If we head over to the Tecton dashboard, that should be triggering a pipeline run shortly.
Yeah. Now something that's important is the Tecton dashboard is something which we're using for our kind of automation engineer persona. But for a developer, they wouldn't necessarily want to interact with this kind of thing. And we've chosen to use the GitHub checks as a way of communicating what the pipeline is back to the application programmer. So as these steps progress through this pipeline, we should see information mirroring that going back to GitHub itself.
So yes, if we check the PR real quickly, we can see here we've got our GitHub checks. They're all queued and waiting to start. The cloning tasks are in progress here. So as Tom mentioned, if you're unfamiliar with infrastructure, it's it is more useful to look at the GitHub checks than the Tecton dashboard. We can see here the tasks are running.
And yeah, the rough outline of the pipeline that we showed earlier in our slides should be reflected by the series of tasks that we're calling here. So some steps that involve cloning our configuration, because configuration is code for us. So cloning that out of GitHub, running a series of Ansible playbooks. So one for allocating the CICS region, compiling everything for CBSA from the pull request, provisioning CICS, then some steps to allow us to interact with Selenium, and then finally preparing and running Galata tests, getting the results, pushing those back to GitHub checks, and then finally cleanup of all of the resources that we use during the run.
And the dashboard is very clear as well. We can see here the status of pods, and the logs from each task as well. So you can see this is cloned successfully, as is this task here. So now we'll head into the allocate playbook. So this is essentially preparing CBSA and the CICS region to be deployed and installed.
You can see if you click on that Ansible playbook task, we've now got that same Ansible logging that you could see locally being reflected back to your dashboard, which will eventually find its way back to the GitHub check once the task is complete. Now, shall we leave that running and we'll wrap up with the slides? We will come back to this if you've got any specific questions. So as we skip the video. So just to wrap up with a quick recap on what you've seen. So you've seen us demonstrate the process that we're integrating into our open source release process. So at a few presentations previously, we have shown what we're doing in CIP towards automation, towards the goal of automating development of our CICS application. This is now the point where we're actually adopting it properly into our processes. So this is what James will use for all future releases of CBSA into the open source. Now, we also have a goal, because we're aware people are interested in testing CICS applications and also in creating their own automation. We also have a goal to contribute what Justin's created here out into open source as well. So that isn't there yet, but we're planning on doing that as soon as possible. So soon you'll also be able to have a look through the playbooks used here for setting up a CBSA environment. And you'll also be able to have some examples, real-world examples of Galata tests running against an application. A few things on optimization. There's a few steps here that could be done in parallel, and doing so is quite easy using Tecton and Ansible. So we will be investigating that. And lastly, there are a few directions that we thought that we could go for next steps for this pipeline based on what other teams are working on in CICS. So right now we're provisioning a single region. We're aware that often CICS applications are actually provisioned onto a CICS or deployed onto a CICS Plex. That would be a more realistic scenario. We're investigating ways to achieve that using the provisioning collection. But we're also really interested in the Z declarative specs schema and CICS config, which are both being worked on with some open source samples available. So looking into new ways of deploying our CICS environment. So lastly, here is our open source repo. All of the application code that you've seen there is available with the intention for all of the automation and the test code that you've seen to also become available soon. So hopefully that's of interest for your own demo purposes or for looking through what our understanding is of CICS application development. And yes, session feedback, any feedback would be really appreciated. It's also Justin's first session at GSE, so it would be nice to get feedback for him too.
Definitely.
Thanks
Yeah.
very much, Tom. And yes,
Thank you.
feedback's very important. You can do it with a QR code on the foils, or indeed you can click on the presentation on the agenda and give your feedback, and it's much appreciated because we want to make the experience as good for everybody. Personally, for me, we've mentioned having a sample application that's more modern over many years, and this is sort of a direct result of customer feedback. So I'm very satisfied with this, Tom, and it's great that you found it, the use for it to showcase other new modernizing features that we can add into CICS as well. So I'm certainly very keen when we get the time that we actually deploy the sample application and try out a few of these things. But it's certainly what customers ask for, and thank you very much.
Thank you. That's great to hear.
Okay, and I made a very bad job of looking at the agenda as usual, so I'm just going to have a quick look. And we've got Ezra Gross coming along at 3 o'clock, showing us how to build a CICS SM system and going through all the basics. So if people are interested, please come back in this room in half an hour. And thank you for your time, everyone, and I'll see you soon.
Thank you.
Oh, there's something in the chat. Hold on, I've just noticed it. Just some nice feedback. Excellent.
Thanks.
Thank you very much.
Just quickly, if anyone has any questions at all, feel free to contact either of us. We're both on LinkedIn, or we've got email addresses in slides.
Yes, and here's quickly, just because the other pipeline has taken a while to complete, here's a previous one that has run. As you can see here, all the tasks were successful. We've got a test report here, so we can see that some tests passed, some tests failed. One thing that was important for us is to ensure that if a test fails, this does not reflect as a failure within the infrastructure, but it will reflect as a failure on the pull request. So the GitHub check will flag as a fail, and this will then prompt James, for example, to go and investigate, well, what's gone wrong with the application. And we'll have a look quickly here, so we can see some of the GitHub checks from the pipeline that's running now have completed, and others are in progress and waiting to start.
Okay, thanks once again, guys, and see you all back here at 3 o'clock.
Thank
Cheers.
you all very much.
Cheers.
Bye-bye.